Welcome to Old School Chemistry. Today we're going to do the ALEKS topic, predicting equilibrium composition from a sketch. So this is going to be a little bit of a thought question, a little bit of math. I want to remind you that when we're talking about equilibrium, our equilibrium constant equals the ratio of products over reactants. So let's look at this together. They give us this tiny sample, pretending that we can see the molecules down at the atomic level, and then they give us the reaction, and this reaction will always be R yields P, reactants yields products on this particular problem. And then they give you K. Now after they give you K, it says the equilibrium constant K for this equilibrium is 1/4. Predict the number of R and P molecules in the sample when the interconversion reaches equilibrium. So I'm going to make a note that we're going to have 1/4, and I'm going to remind you and I, that means for every one product we have 4 reactants. Did you hear that? For every one product we have 4 reactants. So if I were to point this out, if I had just one possible reaction, we would have 1 plus 4. I would have 5 total molecules. Okay, I'm just going to plant that seed for a second with us. Now, let's come and count. I have 1, 2, 3, 4, 5 of my green R reactant and 1, 2, 3, 4, 5 of my gray product. For this problem, they're not asking the direction, they're not asking what's consumed, they're not asking what's going to decrease or increase. All they want to know is once you reach equilibrium, how many particles do you have of R and of P, so when you divide it, products over reactants is 1/4. So to answer this question, really honestly, all you need to know is the total number of particles inside of the container. Let's count the total number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10. So you're thinking, okay, if I have 10 particles, how many products do I need? How many reactants do I need? So it's always 1/4. Well, if it's exactly 1/4, it's 5 total molecules. I've got 10. So how many do I need of each? You can be thinking, how do I get from 5 to 10? I multiply by 2. Multiply that by 2 gives me 10. It means if I multiply this by 2 over 2, 2 eighths. Look at that. 2 divided by 8 is 1/4. That's the ratio. For every one product, there's 2 reactants, which would be the same thing. 2 products, 8 reactants. And add this up. 2 products plus 8 reactants gives you what? 10 molecules. So a teeny bit of math, but it's mostly a thought question. We'll do this again. I promise you'll get it. So look at how you put down the answer. Be careful. In fact, Alex, if you're watching this, please switch those. Products over reactants. Students will make a mistake because they're used to writing 2 over 8. Please switch those. So be careful to my students, okay? Be really, really careful. R, reactants, that's the denominator. We had 8 of those. And products, P, we have 2 of those. Okay, nice. Let's check it. And we will do it again. Okay, we have yellow and green reactants and products. I'm going to count how many total compounds we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 10 total molecules right now. And we know that R goes to P. This also only works in this situation because we have 1 mole of a reactant forming 1 mole of a product. Okay, the equilibrium constant is 5. So let's write that down. K is 5. Now whenever you have a number, you and I know that's understood to be over 1. So that means for every 5 products, you've got 1 reactant. And when I counted this up, we have 12. So if I have to end with my 12, because this is a 1-to-1 ratio, if I have to end with my 12 molecules, what ratio am I going to have here? 5 plus 1 is 6. If I want to end with 12, you multiply that by 2. Let's multiply this by 2 over 2, and look what we get, 10 over 2. 10 plus 2 is going to give me 12 molecules. We'll have 10 products for every 2 reactants, okay? 10 products for every 2 reactants. Let's put it in. I think we need to do it one more time. So, and notice how careful I am for the reactant. I've got 2 of those, and for the product we've got 10. I'm sorry, you know that's kind of confusing how they put that. Let's do one more together. Okay, so this one, let's count our total number of molecules. Again, it's 1 mole of reactant forms 1 mole of product. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 10 total molecules in here. Oh, easy, you've got this. The equilibrium constant is 1. And you and I know that's 1 over 1, right? So I have 2 total. I'd have 1 product, let's write this down, for every 1 reactant. Well, if I want products and reactants total to equal 10, and when I divide those 2 numbers, it gives me a 1, how many products, how many reactants do I need? Let me say it one more time. If I want the products and reactants when I divide them to equal 1, but I need when I add those up to equal 10, what 2 numbers do I need here? A 5 divided by 5. Here we can do it. If I've got 2 here and I want to get to a 10, what would I do? I'd have to multiply that by 5. So I take this 5 times 5. So you could think it out. That one was a little bit easier. You go, oh, 10 molecules. When I take 2 numbers that add up to 10, but I divide them equal 1, you knew it had to be 5 over 5. There's the math though to show it, is that you have 2 total particles, 2 molecules. If I want to get to 10, I multiply by 5, so you just multiply numerator and denominator by 5, you get 5 over 5. So when we have 5 reactants and 5 products, you divide that product over reactant, you get 1, an equilibrium constant of 1. Okay, good work on that. Please like and subscribe if you haven't already, and I'll see you next time. Thanks.